Okay, guys, so today we're looking into acceleration. What I'd like you to do for your starting questions is to fully explain the motion of the objects in these two distance time graphs. So have a look at each of them and then think what is happening to the object in that distance time graph at each stage of that journey. Pause the video, answer the questions, and then resume when you're ready. Okay, so if we have a look at this first one, we'll just call it A. From 0 to this part here, we've got a gradient. And if you can remember from last lesson, a gradient of a distance time graph shows us a constant speed. So the first point we're going to write down is that we have constant speed. Okay, now if we notice that we're traveling from 0 to 12 miles in the space of 2 hours, working out the gradient, we've got a difference of 12 in the y-axis and a difference of 2 in the x-axis, which gives us 6. So it's a constant speed of 6 miles, because that's what our distance unit is in, and then hours is our time, so miles per hour. Then if we have a look at this central part here, we've got no gradient. And if you can remember, when it's flat on a distance time graph, it means the object is stationary. And we can see that it's stationary from 2 hours to halfway between 2 and 3. So it's stationary for 30 minutes or half an hour. And then finally, this last leg of the journey, we've got a distance traveled of 18 miles. So from 12 to 30, we've got 18 miles. Again, because it's a gradient, we know that it's a constant speed. And we're doing that over the course of half an hour. So 18 divided by 0.5. Anything divided by 0.5 is the same as times it by 2. So we've got 36. That means for that last part of the journey, we're at constant speed of 36 miles per hour. Okay? Now if we have a look at B, we've got a gradient here, which is our constant speed. We've got a distance of 60 kilometers, again working out our gradient to tell us what that speed is. Over the course of 3 hours, that gives us a constant speed of 20 kilometers per hour. Then we've got this part here, we've got another flat section, so stationary. If you notice, it's stationary between 3 and 4, so stationary for 1 hour. And then finally we've got this downwards gradient. Again, it's a gradient, so we've got constant speed. We're traveling from 60 to 0, so our difference there is 60. And then we've got a time of 4 to 6, so that's a difference of 2, which means that our gradient is 30, which means we were traveling at a constant speed of 30 kilometers per hour. Now, the other thing if we notice about this graph on B is that this gradient is downwards, so we are returning to start point. Okay. So, talking about acceleration and describing what acceleration is. Some of you might be able to kind of recognize the word acceleration, or if something is accelerating. And an acceleration is a change in velocity or speed. You'll learn in later years what the difference is between velocity and speed, but for now we're going to use the term quite interchangeably. Change in velocity over time, a given time. So, if we have a look at this car, in the space of this 1 second, so initially, at time 0, so before anything has happened, this car is traveling at 0 meters per second. Okay, it's not really going anywhere. Then over the course of 1 second, that velocity, that speed changes from 0 meters per second to 5 meters per second. So we say that there's a difference there. There's a change in velocity of 5 meters per second. Okay, then the next instance, we go again, it's another time change. Sorry, that should be 2. Another time change of 1 second. And then again, we've got a change in velocity from 5 meters per second to 10 meters per second. So again, that's another 5 meters per second change. And then again, 1 second change to another 5 meters per second change. So we say that it's had a change of 5 meters per second per second. So it's accelerated 5 meters per second for every second that passes. So we can say that it's an acceleration of 5 meters per second squared. And by saying meters per second squared, it kind of gets rid of that need to say meters per second per second. Okay, so there is an equation to acceleration, and its acceleration is equal to the change in velocity divided by time. Now there's kind of 2 ways that we can kind of show this equation off. So I'm going to split that down the middle, and then show you both ways. The first one is A equals this little triangle V over T. Now that triangle just means it's delta, it means a change in. So it's basically another way of saying this part here. Okay, whatever your change of velocity is over time. So A is acceleration. Delta V is change in time. And then T equals time. Now the other way that you could have it shown is A equals V minus U over T. Now it looks a little bit more complicated, but it means more or less the same thing, where A is the acceleration again, V is the final velocity, U is the initial, and then T is the time. Okay, so basically by saying the final minus the initial velocity, it's just another way of saying the difference in velocities. Okay, so they both mean relatively the same thing, and if we're looking for our units, we've spoken about them already. Acceleration units are meters per second squared, velocities units are meters per second, and then time is in seconds. So having a quick look at the example, in that first example, we've got our acceleration is what we're trying to work out. Our initial velocity is 10. Our final velocity is 25. And then our time is 15. So by putting it into the equation, we've got A equals 25 minus 10 over 15. So our acceleration is equal to 15 over 15, which is 1 meter per second squared. Now again, if we just quickly do it the other way, we've got the difference, 15 over 15, 1 meters per second squared. But the reason that we might use this way over the other way is it helps us really understand what's going on. Sometimes there won't always be two numbers for you to easily work out the difference. So by breaking it down and thinking what's happening, this kind of method helps us to really appreciate the steps of the question. Okay, a runner starts at rest and accelerates to a top speed of 10 meters per second. He does this in 2 seconds. What is his acceleration? So A, U, V, T. Acceleration is what we're trying to work out. Final velocity accelerates to a top speed of 10 meters per second, and he does that in 2 seconds. Now, because he starts at rest, that tells us that his initial velocity is 0. He was not going anywhere before. So again, we just quickly put that into the calculation. Our u is 0, so it's just going to be 10 over 2. Our final acceleration is going to be 5 meters per second squared. Okay? So, following on, we've just got some practice questions for you to do, and then some exam questions I would like you to have a go at with the mark schemes to help you out. Okay, enjoy guys, bye.